Dear students, here we see the continuation of the previous video. Okay, we see this question. Find integral over C. Here, why we put the small circle on integral symbol, that is closed smooth curve, which means here we are going to deal this contour C as a unit circle, which means that is the circle is a smooth closed curve. That's why here we put this small circle over this integration symbol. Okay, now 3 over I is dz. This we have to calculate. Where what is C? C is a unit circle traversed once counterclockwise. Okay, now already we know that we have seen in the slide 3. If we have the circle modulus z minus z0 is equal to r, then what is the parameterization form? That is z of t is equal to z0 plus r e power it. Here the circle is traversed once counterclockwise. We know that. That's why here we are putting plus. That is e to the power plus it. Okay. Now z0 is the center, r is the radius. Here what is this t? T is nothing but vary from 0 to 2 pi. Okay. This is the limit for t. Okay. Now from the given question we can take what is f of z. F of z is equal to 3 over iz. That is from the given integration. Okay, now here what is the contour? Contour is here. See, what is that? See, that is unit circle. Unit circle is nothing but center 0 and radius 1. That is mod is equal to 1. This is the circle with radius 1 unit. That's why unit circle. Okay, so now how to write the parameterization of the circle? So here this is traversed once counterclockwise, so that now we use this idea to write z of t. Z of t is equal to, now here what is the center? 0. That's why put 0 plus, see here we follow this rule, so center plus r, or radius is 1. That's why here put 1. Then e to the power it, e to the power it, 0 to 0 less than or equal to t less than or equal to 2 pi. It is common for the circle. Okay, so now z of t is equal to e power it, and t varies from 0 to 2 pi. Okay, we have calculated z of t. Then we have to apply this rule. We have to find the function f in terms of t. So that now f of z is equal to 3 over iz is given in the question. So now here this is the value, means this is z. We have to substitute here. This is the z, that is z of t. So is equal to 3 over this z is nothing but this e power it. So I already we have in the denominator, I into e power it is equal to, this is called f of z of t. Okay, now what is z dash of t? As we discussed in the previous two questions. Now take this, from this you find the derivative. Okay, so now z dash of t is equal to e to the power it is e to the power it, and then you differentiate this, differentiate it, so that you will get I. Okay, then you multiply with e power it, I. This is the derivative. Okay, now see, consider this rule, substitute everything. Now here integral over c 3 over I z dz is equal to, this is given, is equal to, what is the limit we have? 0 to 2 pi. So 0 to 2 pi, so 3 over I z is, see, I e to the power it, and then what is the derivative? You see the rule, what is the derivative? So derivative is I e to the power it. Again you multiply this here. Okay, that's why this is the I e power it appears here. This is the derivative. Okay, multiply dt, integrate with respect to t. Okay, so now I e to the power it, I e to the power it cancel, so only 3 remains, so that integral 0 to 2 pi 3 dt. So now 3 is a constant, so integrate dt, that is t, limit 0 to 2 pi. So your answer is 6 pi. This is the value of the, this is the value of this integration over this contour c. Okay, that is 6 pi. That's it. Now we'll see another example. You see, evaluate integral over c z bar dz. Okay, where c is given by x is equal to 3t, y equal to t squared, and the limit for t is -1 to 4. Okay, now you see here Now you see in this question, everything is given. See, what is x, what is y, and then what is the limit for t also. Okay, so now no need to do like to what we did in the previous questions to find the privatization. No, just you substitute this. So what is z? We know that usually what is z is equal to x plus iy. What is z? Z is equal to x plus iy. That is the Cartesian form. So now what is the x here? 3t. What is y here? T square. Just you substitute here, so that you will get z of t is equal to 3t plus it square, x plus I y. So substitute here, and then from this you can find z dash, means derivative. That is, here with respect to t you have to do derivative. That's why 3 plus 2it. Okay, now we have to find f of z of t. What is f of z of t? What is f of z? That is here z dash. This is your f of z. So z dash. So now this is your z. What is the dash? See here 3t plus it squared. That's why we put bar, which means you change the sign of I. So that's why minus it squared. So this is your f of z of t. Then we know that, see, to find the given integration, this is equal to, what is the given limit? Minus 1 to 4. See, this is given in the question. So minus 1 to 4. This is f of z of t. From here, substitute. And then is a dash of t. Here we have calculated, so substitute, multiply dt. Now what we have to do, you have to integrate with respect to t and then substitute the limits. Minus 1 to 4, upper limit is 4, lower limit is minus 1. See here, so that you will get 195 plus 65i. Okay, here is nothing but simple integration and then do simplification. Finally you substitute the limit, upper limit minus lower limit, then you will get the answer. Okay, that's it. Now we'll say another example. Evaluate, you see, evaluate here integral over the closed curve, closed smooth curve, that is the circle. One circle C is a circle, C it is given. The function is 1 over is a dz. Okay, where C is a circle, and here also in this question everything is given. X is given, y is given, and the limit is also given. So just you substitute here. What is it? X plus iy. So now that is x plus iy. X is cosine t plus I, y is sin t. So this is nothing but e to the power it. Okay. Now what is the dash? From this you can find I e to the power it. Okay. Now, but what is f of z? F of z is 1 over z is given in the question. That's why 1 over z is nothing but e power it. So you put e power it here and then write this denominator value into the numerator. It will become e power minus it. Okay. Now we have everything, function in terms of t and then derivative and then limits also. So now substitute everything here, so that integral 1 over z dz is equal to given limit. This is the function, then this is the derivative, then dt. Now e power it, e power minus it will be cancelled because here negative, here positive. This will be cancelled. So e power minus it and e power plus it cancelled. So I is the only remaining value. So I, then integral dt is t. So that upper limit is 2 pi. So 2 pi I you will get. That's it. Now we have another note. You see here integral over closed curve, closed smooth curve, then z minus z naught whole to the power n dz is nothing but will take value 2 pi I. This integration will take 2 pi I if n is equal to minus 1. Here if this n is minus 1, then the integration of this value is 2 pi I, otherwise 0. Integration of this is 0, provided C or is the circle mod z minus z naught is equal to or traversed once in the counterclockwise. This is the condition. Okay. If your C or is a circle mod z minus z naught is equal to or traversed once in the counterclockwise, then on this situation, if you find the value of this integration, that will be 2 pi I if n is equal to minus 1, otherwise this value is 0. Okay, now we will see an example for this. Now evaluate, say integral, our contour is gamma, just nothing but closed smooth curve, that's why I put here circle, 5 over z minus 2 dz, where gamma is the circle. See, mod z minus 2 is equal to 3, which means center is 2, 2 comma 0, radius is 3, traversed once counterclockwise, so that we can apply this. And one more point here to check before apply this idea. Here z minus z naught whole to the power n. Here n, definitely there is no other number is possible. Definitely it is minus 1, then only we can apply this idea. So now see here, 5 over z minus 2, z minus 2 here, degree 1 in the denominator. If you write here in the numerator, it will become minus 1. That's why, okay, you can apply the rule. Okay, understand what I'm telling? So 5 over z minus 2 dz. Okay, this is okay with this idea, so that we can apply this. Now what is the answer for this? Here n is minus 1 and z minus z naught dz integral value is 2 pi I. Similarly here you see, but here one thing is extra appears in the integration, that is 5. So 5 you take it outside, 5 take it outside, then integral dz by z minus 2. Okay, this is the center here given in the question. That's why for this, see, integral dz by z minus 2, I can give the value 2 pi I by using this previous result. Okay, by using this previous idea. That's why here 2 pi I, here I have 5 in the question, so that I multiply here 5. Okay, so your final answer is 10 pi I. Okay, here one more clue is, now you see here, where gamma is the circle, mod z minus 2 is equal to 3, traversed once, so that I am writing here 2 pi I. Okay, for the same question, suppose I give here gamma is the circle, mod z minus 2 is equal to 3, traversed twice, which means you have to multiply here by 2. Okay, if traversed 3 times counterclockwise, you multiply here by 3. That's it. So this is the use of this result. See, if you have similar type of functions over the closed smooth curve contour, then you can apply this result only for the circles. Okay, that's it. Thank you.